Hi friends, welcome to About Civil Info channel. In today's video, we are going to design the simply supported beam for the shear reinforcements. Before going to design, make sure you have liked the video and subscribe the channel. The question is shear design of beam as per SI. The beam shown below, which has the 20 feet length, 18 inches of height, 20 inches of beam width, and D is 15.5, which is not given here. The given data for the beam, so we know that from the question FC prime is 4000 psi, which is equal to 4 ksi, and Fy, which is equal to 60,000 psi. So dividing this by 1000 to roll the number, we get that 60,000 ksi, or simply caps, and ultimate moment, that is 45 caps, which is given. Now this is what the loads and the requirement of the beam is. Now section of the beams, we have height of the beam 18 inches and effective depth of the beam is 15.5 inches, and at the last we have the width of the beam, which is BW is equal to 12 inches. In solution, we have the design for shear reinforcement. We know that ultimate moment which is given to us, that is 45 caps. But we have to find out the 5VC, which is the equation for this, that is phi 2 under the root FC prime BW into D. From this equation we will find out the phi VC value. Now just putting the value, the pi is 0.75, 2 is as it is. FC prime, we have the value for FC prime, which is 40,000, and breadth of the beam is 12 and effective depth of the beam is 15.5, dividing by 1000 because to get the value in caps. So by doing the calculation we get the value of this, which is 17.64 caps. Let's check it once again. It's fine. Now as phi VC is less than VU, so therefore shear reinforcement is required. Now using the stirrups for this, assuming number 3 bars, which usually use in the stirrups for the steels, but using two-legged of stirrups, which area is 0.22 inch square, using what? Using vertical stirrups. Now to find out the spacing required for the stirrups, which is equal to SD, which is denoted by SD. The equation for SD is phi AV Fy into D divided by VU minus V5 VC. Putting value in this equation will get us the spacing required between the two stirrups. So just putting the values, phi is 0.75, AV is 0.22, Fy is equal to 60, and D is 15.5 divided by 45, which is ultimate share minus 17.64. Just doing the calculation, we will get the value of SD, which is equal to 5.6 inches. This is the spacing required between the two stirrups for the ultimate movement and the 5VC. Now, maximum spacing for the design of shear. So there are four formulas we have to use. So the first equation or first formula is for S maximum, that is AVFY divided by 50 into B. Simply say 50 into breadth of the beam. Now putting the value, we know that AV is equal to 0.22, Fy is putting that 60,000 divided by 50 into 12. Now again just doing the simple calculation, which give us value that is 22 inches. Now second formula for S maximum, that is D divided by 2. We know that D is 15.5 divided by 2. So that is very easy now to calculate. 15.5 divided by 2, which is equal to 7.75 inches. Now going to the third formula, the formula for X maximum, that is AVFY divided by 0.75 under the root FC prime BW. Now putting the values, AV 0.22, Fy is 60,000 divided by 0.75 under the root 4000, the value of FC prime, and BW 12. Just simple calculation here again will give us the value that is 23.19 inches. Now we will take the value from these three formulas, which is the minimum value. So the minimum value in these three formulas is, which is the required S maximum length according to ASI, that is 7.75. because now check for the depth of the beam. The criteria or the equation is phi Vs less than or equal to phi 8 under the root Fc prime Bw into D. We will check whether phi V is come less than from this equation or not. So phi under the 8 under the root Fc prime is equal to 4000, B is 12 and D is 15.5 divided by 1000 to take or to get the value in caps. Just doing the simple calculation, we will get the value of phi this equation, which is phi 8 under the root Fc prime BWD, that is 50.8, sorry 58 caps. Now finding out the equation value of phi Vs. So phi Vs is equal to Vu ultimate moment minus phi Vc. Both values are given, so just putting the value of 45 minus 17.64, which is equal to 27.36 kips. Now let's check let's check whether that equation can be confirmed or not. So 5vs is equal to 27.36 less than 5v8 under the root fc prime vw, which is 70.858 caps. So the depth of the beam is okay. No need to increase the depth of the beam. The equation for this, that is if 5v is less than or equal to 5 into 4 under root fc prime bw into d. So we have already found out the value of 5v, so no need for this. Just find out the value of 5 under root 4 under root fc prime bwd. Now simply putting the values, that is 5 0.75 into 4 under the root 4000 into 12 into 15.5, dividing by 1000 to get the value in kips. Just simple calculation here again. So the value which comes from this, that is 35.29 kips. Now let's check it again whether that equation can be accumulated or not. So 5vs, which is equal to 27.36 less than 54 under the root fc prime bw, which is equal to 35.29 kips. So it means that 5vs is less than 54 under the root fc prime bwd. So therefore S maximum is okay. Now let's do the drafting for the beam. Drafting is very easy now. Drawing the length of the beam. This is the length of the beam. It is just the drafting, okay? We know the shear force diagram. So let's draw the shear force diagram. This is the shear force diagram now, because the load which was applied on the beam was UDL load. So the UDL load gave us the diagram in this shape. This is the shear force diagram of the beam. Now the kids see that how many shear force occurs in these places. Shear force diagram is very easy to find, to draw and to find, but sometimes it is very difficult. Now the length of the beam, that is 20 feet, and the ultimate moment which will come in this place at a distance a D from the support, which is 45 kips, 5 VC, which is 17.64 kips, and finally 5 VC divided by 2, half of that, which is equal to 8.82 kips. Same here, means that both are similar. The 5VC value will also be okay there and also there. Now taking this side of the portion of the beam, let's draw it a little bigger. This is the shear force side. Now look at this. This is the one side of the above beam, clear? Now VU, 5VC and 5VC divided by 2. So this is all what we have found.